Let's look at isotopes, isobars, isotones, and isoelectronic species. Take note, for you to understand this term very well, you actually need to watch my previous video where I explained atoms, molecules, and ions. The link to the video is in the description box below, so you can go check it out. Now let's look at what isotopes. Before we define this, let's take a look at these two atoms like this. We actually see that here, the atomic number or the number of proton in this first atom here, I have it to be what? The atomic number or the number of proton is equal to 17. Here, the mass number is equal to 35. And here, if I want to get the number of neutron, you actually know that what? We are going to subtract these two. It means that the number of neutron is 35 minus 17. And what would that give us? That's 18. Let's do same thing here. We have proton to be 17. Our mass number here is 37. And the number of neutron is 37 minus 17. And that will be equal to what? 20. Now, check it out. You see that they have the same number of what? These two atoms have the same number of proton, different mass number, and different neutron number. So we can define isotopes as what? Atoms of the same element with the same number of proton, but different mass number, or you say different number of neutrons. So I will say isotopes. Now, for me to summarize everything that what isotope entail is what? Isotopes, look at isotopes. They have what? Same proton or atomic number, same proton or what? Or atomic number, same proton or atomic number. Next one is that what they have what? Different mass number. And lastly, they have what? Different neutron number. This everything isotope what? Isotope entail. So they are atoms of the same element with the same number of proton, different mass number, and different neutron number. And that is what? Isotope. Alright. The next one is this. Let's look at isobars. Isobars are what? Atoms of different elements. Yeah, different elements with what? With the same mass number but different atomic number. Isobars, they have what? Same mass number but different what? But different atomic number. And if you hear the word atomic number, we are talking about what? Proton. Different what? Different proton. Now let's take a look at one example. Look at this. Now look at this. If you look at this, you see that. I'm coming. Hold on. Now look at this too. If you see that what? They have different atomic number but same mass number. That's like opposite of isotope. And these are isobars. Let's define isobars in details. You see that what? This one is our they have different proton. The proton differs. After that, what else? They have what? Same mass. Let us look at their neutron. How many neutrons do they have? Check, the neutron here is what? The neutron in this first one is what? This minus this will give me 12. But here, this minus this will give me what? 13. So they also have what? Different neutron. Different neutron. And that is what? That is isobars. The next one is this. We have isotones. Isotones are species with the same neutron number. Let's take a look at an example. If I have, let me say I have atom X and I have atom Y. So let's look at this. Can we check it out? What is the number of neutron here? The number of neutron here is 24 minus 11, and that will give me what? 13. And the number of neutron here is 25 minus 12, and that's what? That's also what? That's also 13. These two species have the same number of neutrons, so that's why we call them what? Isotones. And that's their what? That's their definition. They have the same what? The same neutron. So for us to define them in detail, let's see. Do they have the same proton? Different proton? They have different proton, different mass, different mass. But what happened was same neutron. And that is isotones. The next one is isoelectronic species. Now, isoelectronic species, these are species with the same number of electrons. Isoelectronic species, they have what? Same number of electrons. Let's see. Let's see. Look at this. And look at this. Neon. Check. Are they isoelectronic to each other? That is the question. If you look at it, isoelectronic, it means that we are talking about electrons. For my previous video, we've learned how to get the number of electrons here. The number of electrons here at aluminum is actually 13 minus 3 because it's losing 3 electrons, so I have 10 electrons. But neon here, normally it is neutral, so the number of proton and electron are the same. So what's the number of proton? Remember, it occurs in number 10. When you count your first 20 elements, it occurs in number what? 10. So here our electron is equals to 10. So since they have the same number of what? The same number of electron, therefore this species and this species are what? Isoelectronic to each other. Another example. If I have Are they isoelectronic to each other? Let's see. The number of electron here is what? Remember, this is 17, it gains 1, and that is what? 18. That's 17 plus 1, and that will be equal to what? 18 electrons. Let's look at this. The number of electron here is what? 20. It has lost 2 electrons minus 2, and that will give me what? 18 electrons. But here it is neutral. The number of proton and electron are what? The same, 18 electrons. So you can see Cl minus, Ca2 plus, and argon are what? Isoelectronic what? To each other. So these are the basic explanation of isotopes, isobars, isotones, and what? Isoelectronic what? Isoelectronic species. Now let's look at an example. You can pause the video to give the problem a trial. So let's see. I have 32 16A plus 14 7B 31 15 X plus 18 10 Z2 minus, and I have 14 6 I have Y. Look at this species. Can you tell me which one can you call what? Isotopes? Which one can you call what? Isotopes? And which one can you call isotone? And which one can you call what? Isoelectronic species? Now let's see. Do you have isotopes there? Let's see. Firstly, let us experiment everything we've learned in this video. Now let's see. Looking at this one, the number of proton here is what? The number of proton is what? 16. Remember, the number of proton, this is it. And what's the number of electron here? The number of electron here is how many? Check it out. 16 minus 1. That lost 1 electron, and that's 15 electrons. Let's go here. Proton is 7, electron here is 7. Here, proton here is what? 15. Electron here is what? 15. It has lost 1 electron, that's 14. Here, proton here is what? 10. And the electron here is what? What's the electron here? The electron here is 10 plus 2. It has gained 2 electron, and that's 12. And here, proton here is 6, and electron here is what? Electron here is 6. Now, let's check. Firstly, do we have isoelectronic species? Any isoelectronic species? No isoelectronic species. So none of them is, because none of them have the same number of electrons. So I will say I don't have no isoelectronic species. Okay. Next one, let's get the number of neutron. Let's get the number of neutron. That's 32 minus 16 will give me 16. Here, 14 minus 7 will give me 7. 31 minus 15, that will give me 16. 18 minus 10, that will give me 8. 14 minus 6, that will give me 8. Do we have isotones? Check it out. Do we have isotones? Yes. So I will say 3216 A plus and this and 3115 X plus are what? Are isotones. Why? They have the same number of neutrons. And next, let's see this and this also. So I will say that Z2 minus 1018 and 146Y are what? Isotones. Yes, isotones, that's it. So do we have isobars? Check it out. Do we have isobars? Yes. Look at this and this. They are isobars because they have the same number of what? The same atomic number, different atomic number, but same mass number. And that's the definition of what? Isobars. But for isotopes, they have the same atomic number, different mass number. Here, they are having the same mass, different atomic number. So therefore, I will say that this and this are isobars. And that's just it. So that's it. So that's that for that. Let's take a look at another example. Let's look at another example. Can you tell me what are these atoms of uranium? I have 2 atoms of uranium. One of them have 92 here and 235. While the other one has 92 here and 238. So look at this. Are they isomers, allotropes, isotopes, or isobars? If you look at it, they have the same atomic number but different mass number, and that's what that shows that they are isotopes. As simple as that. So the task I'll be giving so that you are going to comment the answer. This is the task here. Look at this. And look at this. Are they isotopes, isobars, or what do you feel? Tell me in the comment section. On this. Good. So that's that for that.